Hello everyone, it's Gabriel with Still Products. Hope everybody is doing well. Hope you're enjoying these videos like I mentioned. We're just wanting to do some technical type of training videos to hopefully support you out there in the field. Today we're going to be talking about a couple of things. One of them in particular is going to be the difference between pressure and non-pressure types of switches. That way you can kind of understand how they function and how everything works with them. So we're going to be looking at a couple of differences between what we carry, hopefully answer some of the questions with them, and there's some good understanding on how they'll function out in the field. So in this video we'll be covering the fiber optic sensor that we carry, and also we'll be covering our proximity sensor. And how they work together, how we've used them out in the field before. And we're also going to be talking about the new Movis twister switch that has a new mount. So we'll be going over a little bit of that, and that'll be kind of talking about a pressure type of a switch. So I hope you enjoy this video, and again, feel free to leave feedback down at the bottom if you want to see more or different things. But I hope these videos are helping you out in the field, and we are really looking forward to a lot of success in 2017 with iDrive. I think we've hit all the right things with the design of the product, and we're looking forward to hearing back from the field and all the success. So stay tuned. We're going to be going through some of the things, and the first one we're going to talk about is the fiber optic, and I'm going to change the camera angle so we can see a little bit of some of the stuff that we're talking about. Thanks. So we're going to start out here talking about a fiber optic, and this is, of course, our stealth fiber optic. This is the IDHF 510-1. This is the one that actually will connect to the iDrive, so you'll see that here in a little bit. But of course, what's really nice about a fiber optic is you can see it's about the size of a pencil tip or a pen tip. What makes that real nice is that you can bunch them up close together, and we're going to give a couple of examples with it here shortly. But I wanted to show you the actual interface. This is called an amplifier, where the fiber optic plugs in. It's plugging in right here, two wires. One wire is a fiber optic that has a mirror that's looking for light, and the other wire sends it back to the amplifier. So that's how a fiber optic will work. So you can see actually the red light right here. I'm going to show you the way it activates. You can tell here by the orange light that's coming on there to the left that says out. You might not be able to see it completely clearly there, but every time it actually reads my finger here, that little out square box right there on the left side lights up. So you have two ways of adjusting this. Right now it's 9999, and that is the closest this fiber optic will get, which is about right here. It's about 1/8 of an inch that you're going to get in that. So now what we're going to do is we're going to start to increase, because right now it's about 1/8, like I mentioned, of distance. So what we're going to do is we're going to touch the minus sign. You can see the minus sign right here. It says up, down. We're going to do down, and we're going to actually go down to 36. So I'm just going to press the minus sign and hold it down. And we're going to keep on holding it down until we get to 36. What this is doing is increasing the depth, actually the distance from activation. So you're going to see how far it'll actually get, and we're going to put a measuring tape to get a good distance of what it is. So it actually will drop down all the way to 36. So I got a measuring tape here, and also just a business card we're going to use as a flat surface to be able to show the distance. One thing I wanted to show here is that I have the business card about 8 inches out, and I'm already starting to get a signal, but it's not an activation, so it's not a clean enough signal. So we're gonna try to set up this fiber optic to where it's gonna receive clean signals, because it's just reflective. It's looking for a reflective type of, and you'll see that once we get to about 3 to 4 inches is where you're going to start to get clean activation. So this stronger the signal. Of course, we set it to 36, so when it would have got to 36, that's the cleanest signal that it's going to get from. Sorry for the out of focus there. Just trying to get my finger. So between 3 to 4 inches with this type of fiber optic right here, which is our thinner fiber optic, we also have a thicker gauge fiber optic that will probably shoot out further, probably about 7 inches, 3 more inches added to it. It's a little thicker gauge. One thing I didn't mention that I think is important too is to talk about the maintenance of this. And of course, these just pop out right here by flipping the lever here, and they pull out. And one thing that's really important to look at is where the fiber optics are sticking out. As you can see, they're barely sticking out. That's probably the best location for the fiber optic to be, outside of the holder. And so all you have to do is unscrew this holder and pull it in and out. If you're constantly pulling it in and out is when you have to do it. Usually if you have just set it and just kind of a set to go type of deal, you'll be fine with where it's at. But that's usually where the fiber optic is you're gonna want the fiber optic to be set at, as far as in this holder right here. So now what I like to show is an easier way of programming this or tuning it in. There's an auto tune feature on this fiber optic, and you can see the tune button right there on the left side. If I press that one time, you'll see that this SE point comes in here, and if I press it again, anywhere that fiber optic's at, it's going to lock it in. It's going to tell you you're at 5002. I'm going to get a little bit closer. I'm going to do it one more time. I'm at 8828 now. You can see the activation locks in there. And I'm going to get as close as I can. And now I'm at 9948. Again, if I go further away, you'll see I'm going to get further away here. I'm going to tune it in. The number should get lower. 2100. And so the further away, and again, what's nice about that is setting this up for somebody. If I'm doing a cheek puff, a lip movement, if I'm doing finger breaking the beam light, and I need to set that distance up, I can do that all here. So those are the main features for tuning it. Now, the other feature that's interesting, and it'll require you to probably use the fiber optic in this case it's this little LD, and you'll see it right there. You can see the LD. If I press that one time, now what I've done, I've flipped the way the fiber optic is used to being seen. So now you see that the activation's always on. What turns off the activation is when I cover it up. So there's no activation. So this is working reversed, right? So normally I have to break the beam, and now I'm actually having to keep the beam covered. And when I get away from it, then it sends an activation to the chair. Where this is really nice as a safety feature. We've used these a lot and seen them a lot on sip and puff drivers. So this will be at the end of a straw. So if they were in latch mode and, for instance, the straw got pulled away from them, it would send a signal to the chair and activate it. So this is a really, really, really nice feature when it comes to the safety side of it. So now I want to start talking about our proximity sensor. So, proximity sensor, just like the fiber optic, no pressure. Where the fiber optic, you have to break a beam. The proximity sensor is a capacitive sensor, so it's just requiring to see you. It's really reading fluids, metals. So a metal piece too will activate it too, not only a human will. So fluids will too, water will. But as you can see here, it doesn't require any pressure. I could just get close to it. And I could set this up, which this sensor is set up right now. I have it all the way out, which means that I physically have to touch the sensor to activate it. Now what we're going to do is we're going to spin this around about 10 times. And you're going to see it's going to shoot out here. So now I don't have to touch it. So that's really nice about the sensor, but sensor sensitivity, it does get sensitive now, because look, now if I just start to touch close to the actual, not even the target, just close to the sensor, it could activate. So again, This is where you would have to play with this. If you were setting this up on a tray, setting it up, in a different way besides using it in a head array or using that. So you have to kind of really play with the distance of that. So you can see here that the proximity sensor, we could set it up to either have touch or extend the distance out. So it's usually set already at a distance when it's in a head array for maximum type of activation. But when you do see it naked like this and exposed so you can adjust it, then you're more than capable of getting a small, fine screwdriver flathead, almost like one that you would use for glasses, to adjust it. Be very careful. You can't hurt it, but you can send it out of whack, that it'd be hard for you to find it, but you could always look for that red light to flash, and that should be signal out to the device. So the last thing I would like to talk about is the Movis Twister. This has a new mount now, a dome-shaped mount, which makes it really nice. It actually will come with Velcro, a snap lock type of Velcro, so you can snap it down in any key areas. What's nice about this, with the twister switches, the egg switches, is that I can get it in any kind of angle to be able to click and activate. But again, this is a pressured switch, which is all mechanicals or pressure switches, which requires me, you can actually hear it clicking, but it's also there's a spring inside of there, so it's requiring me to push hard enough to activate it, and then be able to release it to get away from it. What's different with the sensor, both fiber optic and the proximities, is that I don't have to press on something. For a fiber optic, I need to move into the beam and get away from it. For a proximity sensor, I just got to get close to it and then be able to move away from it. But with this, I've got to get close to it, and I've also got to use force, which again makes a big difference when it comes to people that fatigue real easy, ALS clients, SMA, anybody that's using it that could be using it a lot. You really want to find locations that they're not having to press for a long period of time, because even if you're able-bodied and you're having to press and hold down on this, you're eventually going to get tired of having to press down on it. So you can imagine somebody in a chair going through the same type of struggles too. So this is the Movis twister switch with the dome mount, and again, it's a pressured. All mechanical switches are pressured switches because it requires pressure to activate them. So I hope you enjoyed the video today, and it answered a lot of the questions that you had. Again, we went over the fiber optic sensor that we are selling here. We use the iDrive interface as an example of powering it up. We also looked at the proximity sensor and how that's adjusted manually. And we also talked a little bit about the new Movis Twister with the dome switch. Again, if you have any questions, feel free to write me at gabriel@stealthproducts.com. I look forward to getting any feedback and talking to you and seeing you in the future. So I hope these videos are helping you out again, like I always say. And we look forward to having the next one out there. Thanks.